presentation.
Great, thank you. So thank you for coming along and listening to my talk. This is a topic I'm quite passionate about. It's also great to be given a talk in person the first time in just over 2 years. Hopefully we'll see more of this thing happening later in the year as well, more in-person events. It's great. So I'm not a big one about giving a whole slide about myself. I'll just give a quick thing. So my name's Sean. I'm involved in application security, so this is why I have such a vested interest in supply chains, or more supply chains from the software side of things, and I do a lot of my personal research. So I'm going to start off with 2 questions, and don't answer them now, I'll come to them at the end, but just keep thinking about it in the back of your mind as we go through this presentation. Now, the first question is, would you allow any sort of random stranger off the street to commit code to your code repository? Think another answer for this, but just keep that in mind. And then the second one, if you were an attacker, would you take the easy route or the hard route? So, I think one of the important things is we need to take a step back and see how things have changed over the years, especially when it comes to developing software and including third-party software in there. So when I first started off my career, I started off at a time where third-party software wasn't really that common. Most often, or you would develop things from the ground up. So companies would go off, build out internal libraries, and you'd probably be asked the question, why would you want to use someone else's stuff? Why are you not developing it internally? From a security point of view, this is great. You have better control and visibility into the libraries. From a code reusability point of view, it's not so great. I mean, you're going to reinvent the wheel, there's a lot of maintenance around these packages. So if there's any sort of new functionality or updates that needs to be done, you have to have vested time and resources doing that. So if you shift towards how we approach it today, it's completely changed. So I think of most applications as kind of glue. You take all these different libraries and frameworks and you code them together to form the functions and features that you want. And this is fantastic from a business point of view. What it means is we can get things out faster and quicker with less effort. From a security point of view, though, it does introduce some element of risk. You're taking code, essentially, from outside the organization, including into your software. And this is where the risk starts growing, and it's starting to become more of an issue today. And I'll go through the slides later on. So what I have here is a snapshot from a company called Sonatype. Sonatype are kind of the de facto name in dependencies and third-party libraries. And every year they produce this report called, I couldn't remember the name of it, the State of the Software Supply Chain. So they do that on a yearly basis. And what this shows is just the number of downloads in terms of the increase. So this was from last year's report, 2021, comparing it to the year before, so 2020. I'm really interested to see what this year's report is going to look like, but you can see those numbers there are quite significant. And that is the increase in the number of downloads of the different languages. So you're looking towards something like Java, which is about 71%, JavaScript 50%, Python 92%, so on and so forth. And those are already a high number, and they just keep on growing rapidly. And this kind of forms into that whole point that I was making about the way we change our development strategy. And that's great. I mean, we get everything done a lot quicker. So this does introduce the element of risk, as mentioned. Because you have this third-party code, this means attackers can start leveraging this to attack organizations, or kind of use a shotgun type approach, where they can try to target many organizations. And the way they do that is by different methods. So these are not all the methods that they could use, but some of the methods that they can use to try to target these libraries and target organizations. So at the top is a attack type called dependency confusion. This is quite a relatively new attack type. It was kind of conceptualized last year. This leverages the way package managers work. With package managers, you typically have a public-facing repository. So in the likes of Java world, you've got a Maven, you've got a repository called Maven Central. In Python world, you have PyPy. In JavaScript world, you've got FPM, so on and so forth. And organizations have their own internal private repositories. And these are repositories that aren't publicly facing, or they shouldn't be. They're only private, they're only accessible to that organization. And this is where organizations would place their own internal packages on these repositories. So any sort of software that they're developing, including web applications that are bundled up nicely and can be deployed by some CI/CD way of doing things. Now, dependency confusion takes these two repositories and it leverages the fact that by default, most package managers will attempt to download the package from the public repository first before it attempts any configured private repository. So what an attacker could do is create the same package structure, name and version number, and then they can host it in this public repository. So when the organization comes to the fold and they pick the right version, will download the attacker's package versus the internal one. And this attack type is actually growing quite significantly. I forgot the exact numbers. It is in that Sonnet type report, but it is becoming a big issue. In fact, it's now one of the most common types of attacks on software dependencies. Other examples of type attacks are malicious packages. So this is where an attacker would actually purposely create a package with vulnerability or backdoor in it. And then compromised packages. So this is quite similar to the malicious packages, but this is where it's a legitimate package, but the attacker compromises that account somehow. So they could compromise the author's account or compromise the build structure that builds and deploys that package. And then the last one is vulnerable packages. So these, again, are legitimate packages, but they have some sort of vulnerability in it, whereby the attacker will then go and exploit. And coming towards the title of this talk is, it's becoming a growing risk. So I've personally seen this starting to ramp up. I started giving this talk along these lines back in 2019, which seems quite some time ago. COVID is like time warped us somehow. But I started giving this talk in 2019, and I couldn't wrap my head around the fact that there's a glaring hole, an easy goal for attackers, and I couldn't figure out what they were leveraging it. Fast forward to today, we're starting to see that happen pretty significantly. I just saw a tweet yesterday from Trusted Set, it was something like 280% increase in targeted attacks on supply chains. And here's sort of a rough scale from the end of 2020 all the way through to 2022. So you started off with the likes of SolarWinds, which I'm sure many of you realized or heard about that incident. So that happened in December 2022. And then the latest one actually happened this week, and I'll actually show, hopefully, a live demo of that. So one of the things I like doing whenever I give these talks is to give some real world examples. So it's always good saying, hey, this may be an issue, or this could probably happen, or whatever. This could happen, this has happened. And trying to highlight some cases where it has happened. So probably one of the most targeted repositories at the moment is NPM. So no package manager or module. So this is basically where JavaScript repositories. And there have been numerous cases over the last few weeks and months where attackers have leveraged the public nature of it and started hosting their own malicious packages. So they've done things from typo squatting. Now, typo squatting is where an attacker would try and create a package with a very similar name or notion to the package they're targeting. So an example was Discord with Robobox. There were some NPM packages that you could bundle in your Discord server. The attackers created very similar sounding names. Like I think it was Robobox X Proxy was one of the examples, and so on and so forth. So if you're coming to try and develop this, which package is a legitimate package? That's probably one of the problems that we face today. There's no way of saying, well, this is a legitimate author, this is probably not. And then I think, I forgot the exact article, but also recently, Spring Forward, they were doing research and they found a whole bunch of other malicious packages on NPM. Now, granted, I actually didn't know this, for recently, NPM is actually on my GitHub, and now I'm doing a pretty good job of trying to rid this, but it's basically a losing battle. Because of its open nature, most attackers can just simply go push out their malicious packages. And part of the problem is, you got to be careful how I phrase it. When people are using packages for software, they often come to the incorrect conclusion that, okay, it's an official repository, so therefore everything can be trusted on there. And thankfully, by and large, most packages are legitimate, and unfortunately, there are some that aren't. And this example we have, thankfully, wasn't an illegitimate or malicious package, but it was a package that did absolutely nothing nonetheless. There are 3 files in it. If you try to use this package, it will accomplish nothing. Zero. Nothing. And I don't know why the author created this package. Maybe they were going to do something with it later. I don't know. There was only one version, and it eventually got taken over by the official NPM accounts. This package name was Dash, right? Wasn't named, just Dash. Again, I think they're assuming that people misstart things when they're typing commands. What was worrying and staggering about this is if you have a look at those graphs, the first point in the graph is when that package was released, or when I could do snapshots. So with NPM repository, you can actually see weekly downloads and how many dependents, so how many other packages use this as a dependency. And that first snapshot was taken in 19th of August in 2021. Sorry, that's up with it. And all the way through to just a few weeks ago. And you can see the significant increase. So we're talking about thousands of weekly downloads, and there was about 84, I think, dependent. So 84 other packages dependent have this package as a dependency. And this package does nothing. So that to me points to the picture where people just downloading stuff without actually validating it. Another example, thankfully this one didn't go anywhere, but it could have ended up really bad. PHP. I'm sure we all know or heard of what PHP is. You have really common things such as WordPress running on PHP. And what the attackers did is they managed to do a malicious code commit to the official PHP repository. If they got out, you can imagine the impact that would have had. But thankfully, that code commit was caught before it ever got out anyway. And PHP subsequently changed their whole way they now deal with the code. I think they moved repositories to GitHub and that. But that just shows you the potential for this. If the attacker managed to successfully put a backdoor in there, that would have compromised thousands, if not tens of thousands, maybe even hundreds of thousands of servers, potentially. Log4j. This one came out last year. I remember it fondly because I was traveling on that day. I was trying to multitask as best as I could do while traveling from Bristol. This one, I have mixed reactions about this because on the one hand, it is pretty significant. So Java is very widely used. Log4j is the kind of de facto logging framework. So it is used extensively across multiple applications in Java. So you're talking about web apps, desktop apps, and so the breadth of this was pretty significant. The fact that you could also export it with relative ease. When I say relative ease, it very much depended. So if it was an internally developed web application, it would be pretty difficult because everything you're doing is blind. Whereas if you have open source, you can actually then see things, see the code and all that. Nonetheless, it was pretty significant. They allowed for attackers to be able to do remote code execution. The worrying thing about this is the aftermath. So a lot of these attacks are great, the hub's there, but then you stand back and look at it a few weeks, months later. How many of you think, just as a show of hands, or an estimate, how many of you think that organizations are still downloading about the vulnerable versions of Log4j? Alright, so let's start throwing out some numbers. 1 million? How many do you think it's above 1 million? One person.
1 million what?
Downloads of the vulnerable version of Log4j. Since the December the 10th when it came out. Yeah, sorry, not weekly downloads, but like overall total. About 10 million? 100 million? Not quite that much.
1 billion.
So, since December the 10th, there's been 30, just over, say around about, probably now close to 37.5 million downloads of a vulnerable version of Log4j. And that accounts for 46% of all downloads of Log4j. And the thing at the time that really got me wound up is the way we're approaching this, and I'll come to this a bit later. Ironically, another Java library, Apache Struts. And this one here is pretty significant. The reason why I picked this, and I was debating whether I should still talk about this happened in 2017. Organization called Equifax, which I'm sure most of us have heard about, and it's been subsequent. There's been some time since. That vulnerability cost that company $1.5 billion. But more importantly for me is that vulnerability should have made people aware of the things that you need to do. Back in 2017. So the really frustrating thing for me with Log4j is, when Log4j came out, people should have already been prepared based off this vulnerability. We have people going around not knowing whether we're using Log4j. But this vulnerability here with Apache Struts should have got people thinking about this. And then this week, we find a similar situation. Oh my gosh, another Java library, so doing Microsoft job here. Apologies. And hopefully with this, I'll be able to show you a demo and talk it through a bit. But again, another vulnerability that's come out. Not aware of any attacks yet, but there is a working proof of concept. So, we have these problems. What are we going to do about it? So, this was one of the really frustrating things with the likes of Log4j when it came out. When it came out, we saw many people jumping on it, and it was great. But in my view, we're approaching it wrong. So by that I mean people trying to create standalone scanners, going, hey, we're going to scan your network, we're going to scan all the files on your system, all that. That's great for software that you buy or use open source. Fantastic. But any internal software that you develop, that's not sustainable. And it's a really rudimentary way of doing it. There are ways that are going to be much better at doing it. And as I said, back in 2017, that should have been a long while for you to start doing this stuff. Which is why we went for JK9 and I was so frustrated. But as we see, it's still a problem. We're still trying to solve the same problem using old methods. So the way we should be doing these things is using something called SCA, the software composition analysis. Well, what this does is actually scans the code, generates what's termed a software bill of materials, an SBOM, that then can be used to manage your dependencies in your software. This SBOM can also be scanned by the SCA to determine which packages are vulnerable. So in the case of Log4j, if you use appropriate SCA, you can say, plug in, hey, where am I using this specific version of this package? All these projects, great, now I know exactly where I need to go and update those libraries. Can't update those libraries. I know where I need to focus remediation, so WAF, that kind of thing. You're not dealing with this blindly. And this is what organizations should have been doing back in 2017 onwards. Not throwing network scanners and file scanners and that kind of thing. This is gold. This is how you can help solve this problem. So one of the tools that does a really fantastic job, I don't often recommend tools, I've tried to keep as many tools possible, but I'll make an exception for this tool. This is something I've seen first hand the benefit of. It's a tool called RS Dependency Track, and I'll show you an example of that shortly. In our RS project, it's entirely free. This is a tool that you could probably pay a few hundred to $1,000 or thousands of dollars to use, but it's free. Use it. There's like no reason why or excuse you should be using something like this. And make sure that you integrate this in your build cycle. So it's continuously doing, it's scanning, reporting, continuously triaging the results. It's not a single point in time when this vulnerability comes up. You need to make sure you stay on top of this. This is something I've seen done generally already in the past, where versions will be used at that specific point in time, and then they won't be updated afterwards. It's a continuous process. You need to make sure that you stay on top of it. So what I'm going to do now is I'm going to show you some examples. So let me get cool. So this here is a tool called Dependency Track, as I mentioned. There we go. So I have some projects in here. You can see it's got nice dashboards and all of that kind of thing. But the really cool stuff about this is you can go to your projects, and now you can start seeing the snapshots of where your different vulnerabilities are. So if I can see the first two, so Spring Demo and Jenkins, but don't have any vulnerabilities. I can actually dive into them. You can actually see the components used. So you can now start seeing what makes up this specific version or specific project, and you can even see when packages are out of date. Whether it's not still icon there. But you're probably more interested in the vulnerabilities. So you can actually go in here and you can go with the vulnerabilities. Now you can start seeing a snapshot of the different vulnerabilities and the severity of them. So now this makes triaging the updates, prioritizing updates, even better. So you can start determining from the top, critical, high, maybe medium, maybe lows, and on you go. The other also really important thing is you can, with this tool, come into the components view and then start searching for different components across all your projects. So say, for instance, there's no MVD entry for this, like there was with Spring, which is why you see in that Spring demo, which I took this week, it should be showing vulnerabilities because that is actually vulnerable. But because there's no entry yet in the vulnerability databases, so MVD, some other ones that you can pay for as well, you can't see that offhand, but you know it's a vulnerability. You can come into the component section, search for the components and see where it's being used, and then deal with it appropriately. And as I mentioned, one of the other bits of this was the continuous parts. So this tool has a plugin that allows you to integrate with Jenkins, and you can actually start running this as part of your build cycle. So as you can see on the right-hand side, there's a nice graph, so you can actually see that offhand once you go project, you build, and see how many vulnerabilities you have, and all of that. And you can even go further. So what you can actually do, down at the bottom, is you can have these kind of release gates, what they call their risk thresholds. So you can actually cause the build to fail if it has a certain number of critical vulnerabilities or a certain number of high. You can set the thresholds and whether they're new or existing. So you can now start being reactive rather than, being proactive rather than being reactive. So you can start really tackling this and do it in a continuous manner. So those are the tools that you can use. Now, as I mentioned, maybe a bit more exciting is the Spring vulnerability. So the Spring vulnerability came out this week, 2 days ago, in fact, on Wednesday. And there is, just getting that one up. Cool. So I'm signing up this web app. So this is a Spring web application that uses a vulnerable version of Spring. Nothing really exciting on the app itself. So if you go there, it just returns a simple page. This is a proof of concept, so bear with me. The real excitement is probably lower level, and then the actual exploit itself. So what we have here is some code that's used to run this proof of concept. This is a vulnerability in the Spring MVC model view container. It's a pattern that's used by many web applications in order to represent business logic, data, and then representing that as a view to the user. The interesting bit for the proof of concept is not really in the model, so you can see the model here. It's not important for this vulnerability, it's just some really basic string, which is not exciting, as well as the views. The view could really be anything. The vulnerability itself allows in the controller where you have a bind. This is basically a way of tying the model to your business logic. And we allocating this controller to a resource called pod. And this is where the magic happens when it runs this exploit. So this is Python. When this vulnerability came out, there was a bit of confusion around it. I was baffled to get it working. There were some difficulties between the exploit script itself, was missing some details in it, but eventually it got fixed and people managed to get it working. What this does is actually exploit the vulnerability in Spring, dumps a JSP file on the Tomcat server. So this vulnerability is only vulnerable if you're running Spring. Web app on Apache Tomcat and JDK 9 and above. And it does this JSP, basically whatever you want to include in that JSP. So in this case, the proof of concept includes Java code to execute commands, and therefore you get command intention on the box. It's all there, so it's on my GitHub repository. If you are interested, give it a shout, and I can give the details of that. So the next thing we need to do is actually run script. Can anyone see this, or is it too small? Zoom in. Let's try to see how to zoom in. Anyone know how you zoom in on the Mac? There we go. Thank you. There we go. All right, is that good? Cool. So what I'm going to do now is run the exploit. So this is going to send off the request to the server with the command "kuama." And if it's successful, we should get the user that it's running as. Fingers crossed. There we go. Yeah, it worked. So we've got the kuama running as the root. So I can do runs now. You should hopefully get password file. Sorry, I'm tethered to my phone, so it's probably a bit slow. There we go. Yeah. So that is full remote code execution. Now, whether this can happen without authentication, I don't know. Just my opinions on this, I think it could possibly be so. It uses a combination of the header and post bodies and that. So possible that you could actually execute this without authentication, but I can't confirm that. As you can see, this is pretty significant, and this was just found last week. So the point is, there's all these vulnerabilities out there in libraries, and it's becoming more and more of a thing. So, coming back to those first two questions asked in the beginning, would you allow someone to run some random stranger off the street to run code on your repository? You are, okay, cool. Yeah, the point I'm making is So I'm talking about a private repository. Would you? Yes or no? No? Yeah. So why are we then just putting stuff from a repository where we don't even know the person, we've never seen them? There's no difference, right? We are literally just putting code from the internet off without any validation. Go have a look at that language batch. That's a good example. No validation in that. So otherwise, then people would be downloading it, or hopefully not. So this is why we have to be wary. And I'm not saying we shouldn't trust people. We should by and large, most people are doing a good job. We just need to verify that whole trust but verify. So libraries that you are using in your software, try to do at least a rough review of it. And then from an attacker point of view, why would you want to spend hours and a whole bunch of effort trying to get through to an organization when you can do something like create a malicious package and then get it neatly inserted into an organization or many organizations with relatively little effort. And you're going to get straight away a much better escalated privilege with low effort. So it's going to be running in a production environment, possibly with privileged access to customer data, obviously depending on the application you target. But from an attacker point of view, it's a great way to invest and exploit the victims. The other problem is, there's just, because of that wealth or that volume, and you're talking about if you need to review every every line of code, you're talking about thousands of lines, possibly per dependency, and then dependencies have their own dependencies, and it just gets messy. So trying to manually review every line of code is not feasible. So you've got this kind of needle in a haystack type of thing. Try to find that snippet of code that's hiding in a massive wealth of code. It's going to be really difficult. So, just ending off, I think the closing thing that I would like to say, while it's going to be difficult to tackle this problem, and there's different things out there, such as Google Solstar, that are trying to look at tackling this problem. We have to start with somewhere. And if going back to the way we approach things like Log4j, we're not even starting off there. We're still doing the whole things. So my view is, if we can just start looking at using things like SCAs, that's a good starting point. That's going to put us in a good position to then move forward and have anything else that comes up. We start validating authors and different dependencies and all that kind of thing. So we just need to start with somewhere. We can do that. There's tooling. It's not cost prohibitive. We should be doing that. So, thank you. Been great to give us talk to you all and finally talk to people's faces rather than some webcam. This has been fantastic. And yeah, any questions? Yeah.
Okay, up the back.
The majority of organisations have got zero control over their code. So how are they going to do this? If it's all compiled.
What do you mean zero control over the code?
Windows, VMware,
Yeah,
applications, a bit all.
so that I would view as more of a supply chain issue rather than a software supply chain. Or software supply chain, I mean those organizations that are using dependencies and frameworks for their own code. So in terms of software supply chain, yes, I'm going to have to rely on a vendor. This is where you can start holding vendors to account. So things like when Spring or Log4j comes up, you start posing those questions to those vendors. What are you doing about this? How are you protecting me? And then also reading out things like security advisories from those vendors is a really good place. Because this should start, if they are affected by that, they should, or even if they aren't affected by it, they should have some write-up informing their users of how they're reacting to it, and what their users need to do.
So at what point is it the package manager's responsibility as the people who take our repository to step in when vulnerable code is published? So I know NPM is quite good at practice at completely removing that, but a lot of code reference of that was still significant amount of downloads.
Yeah, so I think the trouble is with vulnerable versions and malicious packages, right? So NPM, I could be wrong, but as far as I know, they don't remove vulnerable versions from their repositories. If they did, they'd probably break a whole bunch of things. Malicious packages, there's obviously a very valid reason for removing it. This is why organizations need to invest in their own repositories so they can have control. There are tools like Sonatype Firewall, where you can start setting up policies. Using one organization, it's really great. We can start setting up policies where you can't even call them as vulnerable versions. But this also leads to another important thing that many people forget is with a lot of these package managers, a lot of the dependencies are cached. So it's all very right, we have these malicious packages and something like NPM. That's pulled into your private repository. That's not going to go away until you physically remove that. You remove it from that repository. And then having things like SCA that you're constantly monitoring. So this is, you could argue that the repository managers could do more to help, but it's a difficult one. But organizations really need to take control of this.
So I was curious more regarding the contribution stuff that I mentioned before, that a lot of the package managers do grant the public version before the private version.
No, so what they'll do is, say you have a package called XYZ version A. The dependency manager will go on the public repository first, try download from there. It's not that they're not on the private repository. So attackers would then go and create dependency XYZ version A in the public repository.
Cool. Yeah, that's what I was trying to say as well. But and then I was curious to know if there's any public example, like, because I assume that if that's been the case, then there was a leak of how that package looks like in the private repository, so it can be personal and public, right? So do we know if in case this point we know that that is happening how which happens?
Publicly, I don't know. Sonatype, unfortunately, in their report, I wish they did, they would include some examples, but they don't. They just say, yeah, it's the biggest. So I totally get what you're saying, especially if it's an internal package. You have to kind of treat it exactly the same, otherwise you the alarm bells. I think sometimes organizations build their own internal packages as well. I know Google do this themselves. They don't actually download packages. So obviously they have some firewall, I don't know, where they build it internally. So that could maybe be a way to get access to the source code, because it's open source. But unfortunately, I don't know. I just know that Sonatype in the report says the largest attack package. Cool. All right. Well, thanks, everyone.